This is Chapter 2, Functions and Graphs, first section, the modulus function. So the modulus function is used an awful lot in mathematics, especially when we're talking about the difference between numbers. So the modulus is the non-negative numerical value of the number. So if I have a number like minus 7.1, the non-negative of that is 7.1. And we write the modulus with two lines here. So the modulus of A, whatever A is, will be the size of A, the value of it. So let's think about a number line. If I've got a number line here, the difference between 4 and 7 is 3. There's 3 actual jumps between them. But depending on how I write the sum, I can get either minus 3 as the answer or 3. 4 minus 7 is minus 3. 7 minus 4 is 3, but the difference between those sums is still 3. So we use the modulus mostly to express differences, and this way of getting around the problem with what's the difference between a number. So the difference, the modulus of b minus a is 3. So the modulus of that is still 3. Now let's have a little think. When we do mechanics, we come across the idea that things are both scalar quantities and vector quantities. A scalar just has a magnitude, a size. A vector has a magnitude and direction. So let's think about distance and displacement. If you walked across my classroom, it's about a distance of 6 metres. So you would have travelled 6 metres, and your displacement from where your starting point would also be 6 metres. Now say you choose to walk back to where you started from. Your displacement is now 0, but your distance for walking is 12. So displacement and distance are not the same. So you could argue that your magnitude, the distance you walked, is the modulus. And this is how we use it in mechanics. So we use exactly that same notation. This notation here gave us the magnitude or the length of a vector. So let's do a couple of examples. So here I've got f of x is the modulus of 2x minus 3, and I want you to find when x is 5, x is minus 2, and when x is 1. Stop, just scribble down the answers now. Thank you. Let's look at the first one. Well, the first one is fairly straightforward. When we put 5 into there, we get 2 times 5 minus 3. Our modulus is, we've got the modulus of 7. Well, the modulus of 7 is just 7. Let's look at the next one. We put minus 2 in. 2 times minus 2 is minus 4. Minus 3, we get minus 7. So the value inside the modulus sign is minus 7. So the modulus of minus 7 is 7. Now, let's try what happens when we put 1 in. If we put 1 in, 2 times 1 is 2, minus 3 will give me minus 1. The modulus of that is 1. We can take this idea a little bit further and draw modulus graphs. So let's take one of the simplest graphs we could draw. What happens when y is modulus x? Well, when x is minus 2, the modulus of minus 2 is 2. So we'll plot that one on the graph first. When x is minus 1, its modulus is just 1. When x is 0, modulus is 0. When x is 1, it's still 1 and 2. And if we notice, we've now got a V-shape to create the modulus graph. So when you had y equals x, you would have expected a line down here. And you should notice that your line has been reflected in the x-axis to go up into this quadrant here. So now we're going to look at sketching and solving various equations using graphical sketches. So first I want us to sketch the value of y equals modulus 2x minus 3. So when I sketch this, I'm going to sketch, what I would normally sketch is the value of y equals 2x minus 3. And then, with the dotted line, this part below, I would ignore this part and reflect it here to create this. So I sketch my normal graph in, and then I do a reflection of anything below the x-axis to create my modulus graph, because my modulus graph is always the non-negative values. So this is my sketch of y equals the modulus of 2x minus 3. Now I'm going to solve. Modulus 2x minus 3 is 5. So again, sketch the graph, and this time I add the line in y equals 5, and I can see there's going to be two solutions. And what I can do is use my point of intersection here, and this is the original unreflected graph, and I can put y equals 2x minus 3 equals 5, x equals 4. I can solve the equation. For this point here, this is the intersection with the reflected graph. So this is the negative version of that graph. So everything in this part here will be the negative version of it. So the negative version of the minus 3 will become 3. So it's 3 minus 2x is 5. And again, I just solve that. So either x is minus 1 or x is 4 as my solutions. Now, I want to solve this graph here. So I'm going to draw a graph of these two lines and see what happens. And when I draw them, I get my 3x minus 5, which I've used from the previous one, and I put my 2 minus a half x. And here, again, I look for the intersections. And at the intersections, I do two versions. I do the positive version, which is the easy bit, which is just 3x minus 5 equals 2x minus half x. And then I do the negative version, the negative arm of the graph, which is the negative version of the modulus function. So that's going to be 5 minus 3x equals my other function, and just solve that. Now this time I want to solve this for where this is greater than 2 minus a half x. Well, I've already done the bulk of the work here. So all I need to know is the points where the graph of my modulus function is above my other graph. So I'm going to look at where my points of intersection are, and I can see that this is going to be, this modulus function is above in this arm here, and it's above in this part here. So I just need literally to write that part in like so. So I've got various ones here to test your understanding. I'm going to give you a minute or so to have a go at that. Sit down, try them out, and then resume the PowerPoint. Okay, let's look at the first one. Well, the first thing I will do is I will draw a graph. If you don't draw a graph, this one will go wrong, I can promise you. It possibly has gone wrong if you haven't done that. So if you draw a graph, you'll immediately realise that this line here is steeper than this line here. It's never going to cross it. There is only one solution here. So that's the important thing to notice. You only have to solve it for one part. So it only reflects with the negative part of the graph. So if we look at that part, we need to now take the negative version of this, which is minus x minus 1, and set it equal to 2x plus 5. And we just solve the equation as normal, and we get x is minus 2. So you need to be careful. This is why you must always draw a graph. Okay, so this one is solve the inequality. The modulus of 4x minus 4 is less than 2x. Again, you must draw a graph. Now, if you draw a graph this time, you notice you're going to get two critical points. So you now need to determine your critical values. So if we take the positive axis first, which is the easiest one to do, I don't know, I mean, I would always do the positive first because it would make it, I always pick off the easiest part to give myself a little bit of confidence. I'm going to find x is half. Then I'm going to look at this axis here. Well, I'm going to take the negative version of this, so that's going to be 1 minus 4x. Set it equal to my 2x. Solve that, I get x is 6. So my critical values are 1/6 and a half. And because I want this to be less than, this part here is less than this line, so x is between them. And you can see how the graph leads you to the correct answer. So, over to you. I would like to attempt exercise 2A on page X18. Please give a copy of that to me over showing my homework. And also, would you contact me with any ones you can't do, and I will produce a small little film on YouTube so that we can answer them. Thank you.